This is example 9 from lesson 4.1. A bicycle wheel rotates at 2 revolutions per second. A. Find the angular speed in radians per second. B. How fast does a bicycle travel in feet per second if the wheel is 2.2 feet in diameter, round to the nearest tenth? Alright, so for part A, we are asked to find the angular speed. And what we currently know is that the wheel is rotating 2 revolutions per 1 second. To convert this into radians per second, we know that there are 2 pi radians in 1 revolution. And when we multiply, the revolutions will cancel out, and so the units in our product over here is going to be radians per second, and that's what they asked me to do. So if we multiply fractions, we multiply the top times the top, 2 times 2 pi. This is 4 pi. In the denominator, 1 times 1, that's just 1. So it looks like the angular velocity is going to be 4 pi radians per second. All right, now for part B. How fast does the bicycle travel in feet per second if the wheel is 2.2 feet in diameter? Well, if the diameter is 2.2 feet, then we know that the radius is going to be 1.1 feet. And we're going to use the formula V is equal to R times omega to solve this. Now remember, V stands for the linear velocity, R is going to be the radius of our circle, 1.1 feet, and then omega here, this is our angular velocity, which we just found to be 4 pi radians per second. So the linear velocity is going to be 1.1 times 4 pi. And the 1.1 is in feet, and the 4 pi is in radians per second, and the feet will overtake the radians, and so our answer is going to be in feet per second. And it looks like when we multiply this out, we're going to have 4.4 times pi, and then we'll need to put that in our handy dandy calculator and round it to the nearest tenth place. And this is going to give me 13.8 feet per second. Example 10. A sprinkler rotates through an angle of 120 degrees and sprays water a distance of 30 feet. Find the amount of area watered. Round to the nearest whole unit. All right, we're going to use the formula A is equal to 1/2 times R squared times theta. Now remember, theta is going to have to be in radians, and the angle that they gave me was 120 degrees there. So the first thing we're going to need to do is take 120 degrees and change it over into radians. We're going to multiply by pi over 180 degrees, and the degrees are going to cancel out. This is going to give me 120 pi over 180. And then since both of these end in 0, I know 10 can go into both of them. That's going to give me 12 pi over 18. And I believe 6 can go into both of these, so that's going to give me 2 pi over 3. So my angle theta is going to be 2 pi over 3. All right, so it looks like the area is going to be 1/2 times 30 squared times 2 pi over 3. So this is going to be, let's see, we got 1/2 of 900, that's 450, and if we divide that by 3, that's going to give me 150, and then times 2, this is going to give me 300 pi. And our units are going to be in square feet, and when we put that in the calculator, that is going to give me 942 square feet when I round it to the nearest whole number.